These are the lesson activities for Math 117 for Lesson 4.6. A small country of Calavos has 3 states, Bama, Tecos, and Illinois, a total population of 20,000 and 200 seats in the House of Representatives. Determine the apportionment of the 200 seats under Hamilton's method. So this is a review from the very beginning of the apportionment chapter. So we start the same in almost all of the methods by calculating the standard divisor, which is the total population divided by the number of seats to give out, which comes out to 100 people per seat. Then we calculate standard quotas by dividing each state's population by the standard divisor. So 940 divided by 100 is 9.4. Then 90.3, 100.3, and that should add up to exactly 200 seats. Okay. Now, for Hamilton's method, we do the lower quota. We round everything down, 9, 90, 100, which only adds up to 199 seats. So I have to decide who gets the one leftover seat, and we decide by looking at the decimal piece of each standard quota. And we give the extra seat to the largest decimal, so that would go to Bama. So we're going to give Bama 10, and then Tecos 90, and Illinois 100, and that adds up to 200. Now imagine that overnight the number of seats is increased to 201, but nothing else changes. We just have one more seat that we get to give out. Recalculate the apportionment using the new number of seats. So we start with the standard divisor, which is 20,000 people divided by 201 seats, which is 99.5. I'm just going to round it to 99.5. It's pretty close. Okay, then we divide each state's population by 99.5. So 940 divided by 99.5 is 9.447. And 9030 divided by 99.5 is 90.75. And 10,030. So we divide that and we get 100.804. You add them up. I did round these a smidge, which means when you add up what we've written down here, we might get something slightly off from the 201 seats, but this should be approximately 201. Okay, lower quota, we get 9, 90, 100, which is again only 199. And now that means I have 2 extra seats to give out, because remember we have 201 seats now. So we're going to give them to the 2 largest decimals, which would be Tecos and Illinois. So we have 91, 101, and 9. And that adds up to 201 seats. Okay, so thoughts are that Bama is very mad, right? Because when there were only 200 seats to give out, Bama got 10 seats. Now there's another seat. There's more seats to go around, and Bama lost a seat. Bama gets fewer seats when there are more seats to give out. More seats to give caused Bama to lose a seat. So the result we just looked at, that's called the Alabama paradox. It happens when an increase in the number of seats to be apportioned causes a state to lose a seat. The name comes from the 1882 apportionment of the House of Representatives. Here's a summary of what was being debated. When there were 299 seats in the legislature, the apportionment was 8, 9, 18. 8 for Alabama, 9 for Texas, 18 for Illinois. And then we increased that to 300 seats, and it went 7, 10, 19. So Texas and Illinois each got an extra seat, and Alabama lost a seat. So there was an extra seat to give out, and Alabama ended up with fewer than they did before. In the year 2525, the 5 planets in the Utopia galaxy finally signed a peace treaty and agreed to form an intergalactic federation governed by an intergalactic congress with 50 seats. This is the story of the 2 apportionments that broke up the federation. Okay, use Hamilton's method to calculate the apportionment in the year 2525 using the info below. All right, so remember there's 50 seats to give out, so the standard divisor is always total population, which is 900 divided by 50, which is 18, right? 18 people per seat. So for every 18 people in a country, they get a seat in Congress. So I'm going to take each state's population and divide by the standard divisor, 18. All right, so I get 8.33, 4.33, 9.611, 11.33, 16.388, and that should add up to exactly 50. Okay, the lower quotas would be 8, 4, 9, 11, and 16. Let's see, that adds up to 8 and 4 is 12, and 9 is 21, and 11 is 32. 40, that adds up to 48. Okay, which means I have 2 extra seats to give out. I'm going to give them to the largest decimals. So the 0.6 is the largest, and then 0.38 is bigger than 0.33. So I'm going to give it to Coney. They get an extra seat, and Elysium, they get an extra seat. And the others just get their lower quota. And that's 50 seats. Okay, after 10 years of peace, all was well in the Federation. The intergalactic census of 2535 showed a few small changes in the planet's populations, which we can see in the table. What is the new apportionment under Hamilton's method? Okay, so just so that we can compare, A has the same population, B has the same population, C, their population increased a bit, D, same, and E, increased a bit, okay? So everyone has the same or more population from what they had in the previous Congress, which means you would expect they would have the same or more seats in Congress. They should have the same or greater representation if you have the same or greater population. So we're going to go ahead and do Hamilton's method here. We start by calculating the standard divisor, total people divided by number of seats, and we get 18.18. I'm going to divide each state's population by 18.18. Okay, with those calculated, we now do the lower quotas, which we get by rounding everything down. So we have 8, 4, 9, 11, and 16, and that adds up to 48 again. Now we give out the 2 extra seats to the largest decimals. So I would give, the largest decimal would definitely be 0.95, and then after that would be 0.29. Would be bigger than 0.28, 25, or 22. So it's going to go to C and B. So 10, 5, and everybody else gets their lower quota. And we've now given out 50 seats. Okay, thoughts. So let's see. Alanos, planet A. They had their population stayed the same and their apportionment stayed the same. They're fine. Okay. B, population stayed the same. They gained a seat. A little weird, but they're not mad about it, right? Now they have more representation than they did before, even though their population hasn't changed. Okay, C, their population grew and their apportionment stayed the same, which is a little like, they might be annoyed by that. Okay, D, population stayed the same, apportionment stayed the same. And then E, their population grew and they went from 17 seats to 16 seats. So E is definitely mad. Very mad, right? They have their population grew, but their representation decreased. So that's called the population paradox. It happens if a state's population goes up, but the number of seats it is apportioned goes down. Okay, one more example. For a change of pace, we're going to do a non-political apportionment problem. A garbage company serves Northtown and Southtown, and the company has 100 garbage trucks. We're going to apportion them. How many of those trucks should go to Northtown? How many should go to Southtown? And we're going to use Hamilton's method. So we'll start with the town. We have north and south. And then the populations will be 10,450 and 89,550. And then total, that makes up 100,000. Okay, so 100,000 homes. So we start by calculating the standard divisor, which is the total number of homes in this case, divided by the total number of trucks. And that comes out to 1,000, right? Homes per truck. So for every 1,000 homes in a town, we send one garbage truck there. So we're going to calculate the standard quotas by dividing each town's population by 1,000. So we get 10.45, 89.55, and that adds up to exactly 100 trucks. And then the lower quota, we round down to 10 and 89, and that's only 99 trucks. So we send the extra truck to the town with the largest decimal, which would be Southtown. So my final apportionment would give one more truck to Southtown, 90, 10 to Northtown, that is 100 trucks. All right, so the garbage company has just been hired by Easttown that has 5,250 homes. To accommodate the new town, the garbage company decides to buy 5 new trucks because it's 1,000 homes per truck, 5,250. They should get about five more trucks, so that the service to other 2 towns won't be affected. So if we carry out Hamilton's method with the additional town and 5 additional trucks, let's see, we've got the town, we have north, south, and east, and total. And then the populations, 10,450, 89,550, and 5,250. That comes out to 105,250 homes. We calculate the standard divisor by doing the number of homes divided by the number of trucks, which is now 105, because we used to have 100 trucks, now we have 105. And that makes the standard divisor 1,002.38 homes per truck. All right, so now we calculate standard quotas by dividing each state's population, each town's population by the standard divisor. So I went ahead and did those calculations. Here they are. And then for lower quota, we round them all down, 10, 89, and 5. So that's 99 plus 5 is 104 trucks. We have one extra truck. So we should decide where to send it by looking at the decimal portion and choosing the largest. It looks like Northtown has the largest decimal, 0.42 compared to 0.337 and 2375. So we give the extra to Northtown. They get 11, 89, and 5. That makes 105. Okay, so the thoughts. It's a little weird that without changing its population, Northtown gained an extra truck and Southtown lost a truck. So Southtown's going to be annoyed. They are not getting the same level of service they did before because this company took on Easttown. Okay, so Southtown is mad. So this result is called the new states paradox. It happens when the addition of a new state, or town in this example, with its fair share of seats affects the apportionment of other states.